No.
No, can you hear me, madam? No.
Okay. So may I know the next participant? NS101 is ready. NS101 is ready. Hello? NS101 is ready. Yes? You can share your presentation. Ma'am, can you share your presentation?
Just a minute, ma'am.
Okay. Panel members, paper ID NS101. Please make a note, paper ID 101. Yes, ma'am, your screen is visible. You can start. What happened? I don't know. Ma'am has left the meeting. Any other participants are ready?
Two is what? No, I do. I do not. Name I know. Second is 104. Yeah, again.
Hello, sir.
Yes, madam.
Yeah. Now it's visible, ma'am. You can present it. Any other participants are ready? Please let me know. Paper ID 107 is there?
Hello.
10.
Hello?
Hello, ma'am.
Ma'am. Tell me.
Hello, am I audible, ma'am?
Yes, ma'am. You are audible. Tell me. Ma'am, you are audible. Tell me.
Yeah, ma'am.
Hello? Yes. Tell me, ma'am. Ma'am? Yes, you can share your screen.
Right now I am sharing.
Ma'am, what is your paper ID, ma'am?
105.
105. NS 105.
101. Yes, ma'am. Sure.
105.
105.
5.
Ma'am, can I start?
Yes, ma'am.
Ma'am, just a minute. Good afternoon, ma'am.
Good afternoon, ma'am. Your screen is not visible, ma'am.
Ma'am, just a minute.
Ma'am, now it is visible.
No, ma'am. Ma'am, forward to
Ma'am,
me,
it's
ma'am.
now.
I will share it.
Okay, fine, ma'am.
Forward in the group, ma'am.
Forwarded in the
105.
Ma'am, only admins can.
Okay, ma'am. Fine. You forward to seminar email ID, ma'am. You have already forwarded, ma'am.
Yes, ma'am, already it's
by
forwarded.
name of
When,
Through
ma'am? Which?
Ambika.
Ambika.
Yes,
Outlook
ma'am.
mail. Ambika.
Out.
Ma'am, with the help of
Study on
Outlook
impact
mail.
of NPTEL certification on ability, employability.
Yes,
The
ma'am.
same thing.
Yeah, ma'am. Yes.
Just give me 1 minute, ma'am. I'll share it. I could not able to share it. Why? It's in PDF.
For example, we will use topics to write a report. We will have the textile powder, right? And that part, less than that particle, the nanoparticle will be there. And it will be undetectable to our human eye. And it takes place in the physical and chemical properties. As per the physical and chemical properties, it differs in size, as per shown in the images. For example, in physical properties, this may be the shape and size, and for the chemical, that may be the shape and size. It varies from layer to
Hmm. Not able to open.
Good afternoon, panel members. My name is Jagdishwari Durga CH, presenting from Nagarjuna College of Management Studies. My topic for the day is a study on impact of NPTEL certification on employability and career achievement. As we all know, this era is of digital era. So, because of digital era, plenty of students are unaware of like digital education. So because of introducing digital education to the present scenario or present trends, the government has come up with the courses like MOOCs with the help of NPTEL. And the NPTEL courses has been introduced to upgrade the students' knowledge, skills, abilities, and structure them for a massive development in the field of education as well as to build standard of living in the field of employment. So they are meeting the standards of present scenarios, like either within the boundaries of the countries or exterior to the boundaries of the countries. As we all know, the technical scenarios are upgrading each and every day within the external markets, like global markets. To match up with the global markets, we need like standardized education with the present scenarios or with the present trends. So to meet this standardization, we need to upgrade our education system. So to upgrade this education system with the help of NPTEL and as a joint with the help of government and with the help of IITs and IISCs and MOOCs has placed a massive role to upgrade students in educating online educations to maintain standards and stabilities up to the mark. So this standards and this mark will help to gain higher knowledge, to upgrade their skills, enhance career opportunities. They can shape their growth. Not only like this is not confined to a single field of education, like it is spreaded all over to the different parts of education, like engineering courses, MCAs, MBAs, like even it is including to the UG courses, as it is like they are aligning their subjects towards UGC courses. Like as we all know, UGC, they are matching up these subjects with the, as I said, UGC curriculum will be matched with the NPTEL courses, or NPTEL courses are matching with the UGC curriculums. And these UGC curriculums, where the basic things are being learned in the colleges, the exterior things or the upgradation skills will be added with the help of MOOCs as NPTELs. So majorly, the major impact of this NPTEL is to upgrade and job readiness, like promotions, to increase standard of livings of the people, clear in academics, gain higher knowledge, to shape their career growth, So this is how the like NPTEL is going to help this is not only confined to our students or the people, not only confined to our students, it is like spreaded to the faculties, to the people who are working within the organization. So like there is no terms and conditions existing with the NPTEL courses. Sorry. So because of unrestrictive learning process which is being implemented by these NPTELs, massive development has been taken place for the growth and development in the field of education, in the field of employabilities. The major purpose of this NPTEL is to assist NPT influence the people to upgrade their salary, to receive a hike in the salaries, uh, promotions, identification, recognitions. For if any employee, if they want to upgrade the skills, upgradations in the form of salaries, appraisals, in such cases, these add-ons will help to develop the add-ons will help to add their skills and to improve, helps to improve their performances. And later on, major challenges were faced by the learners of NPTEL, but after joining to the courses like NPTEL and other online curriculums or online courses, obviously these people says that like plenty of upgradations are being added to their skills, and there is a lot of progress, there is a lot of change in their salary system, in their knowledge, in their skills, in their presenting way of presentations, in their upgradations. So these are the major objectives which is being placed under NPTEL. The main scope of the study is it is for different streams, not for it, like it is not meant for a single people or a single department. It is allowed to all the learners massively, like to the students, to the people of undergraduates, graduates, qualified people, like the people who want to upgrade themselves. Literally, NPTEL is providing substances or resources which are the changes which is taking place in the global market. Whatever the present condition or scenario which is existing in the global market, the same changes are being implemented in the field of NPTEL. So that is the reason how a tremendous change is being implemented, can be taken place by the learners. And it is not only confined to a particular place or a particular person or a particular department. It is focused to all learners. No geographical restrictions are being confined to this course. When it comes to review of our uh, literature study, so few of the people, few of the scholars says, like they have gave on the base of majorly with the help of engineering students, there is a lot of technical upgradation which is implemented by learning MOOCs, add-on courses with the help of existing education system, what they are educating in the college or within the college premises. Along with that, when they are going through a MOOC system, they are adding higher skills than that of existing skills what they are gaining from the college scenarios. And they're like they can when it comes to a point of interviews, when it comes to a point of placements, obviously these people are preferred more at the time of um, recruitments. So here, like we took for the 2 years, uh, as we saw in the previous slide, Singh and Mehta. According to him, he given some statement that there is an enrollment list which was taken. Enrolled people was 1,133 and registered people were 278 and certified people were 105. and certified rate was 37.77. And for the next period, like 24,840 compared to 2023, because of massive development, massive change in the add-on skills, the number of registrants has been increased in the year 24. The 24 enrollments were 1840, and the registrations were 693, and certified were 59, and the rate of clearance is 8.25. And along with this information, just like the students of Nagarjuna College of different departments, like engineering, BCA, UG courses like BCom, BSc, and BCA, we have recognized 30 participants or 30 students who underwent with these NPTEL courses. They have given their like viewpoints. Massive changes has been brought among themselves, within themselves, by joining to these courses, NPTEL courses, like add-on skills, more like compared to the existing subjects, like more number of information, a large scale of information is being invited by these people, implemented, and along with that, like they learned plenty of different criteria which are existing in the market, and where they are unaware of with present status of global market scenarios as well as current market scenarios. All the like extra information and additional information is being received by these students who has applied for the add-on courses, like joined for the NPTEL courses. And below that, I have mentioned a scale result. When it comes to like with the help of questionnaire, we have interviewed these students, like online learning through NPL. There are like 20 out of 30 students, 28 students has said it is like more beneficiaries, like beneficiaries compared to existing scale of learning. These online courses will add more beneficiaries. And when it comes to teachers, occupational success, like the n number of students who are attending for recruitments, or what we call it as uh, so final year, especially when it comes to the final year students, most of the final year students are placed on the base of their resumes with the help of add-on courses. So this is along with when it comes to a teachers or a faculty's professionalists. So here they prefer that, like more and new subjects can be learned, new add-on courses, multiple courses can be learned, where we can grab multiple uh, cross diverse information can be received with the help of these MOOCs courses and NPTELs. So when it comes to matching competencies, most of the people, when they are adding with the add-on courses, they are moving ahead with the competencies. They can compete with the other criteria members, not only with the faculties. It's also a study with the students. They are competing with their own existing education and with the add-on courses. So more number of students says like plenty of skills and knowledge has been acquired, and motivation, they are being motivated, because when they are acquiring a lengthy of knowledge, huge full knowledge, or credited knowledge, obviously they are they are like feeling they are motivated when it comes to uh, expression of their views or regarding their subjects. uh, before NPTEL courses, like they are like dealing with insufficiency of information. Once they are like joined to these NPTEL and MOOCs courses, obviously their information has been they have gained plenty of information or plenty of information. Because of that, they feel they are highly motivated, and their abilities have been increased. And learning personalities via MOOCs will help more than that of existing scenario, which is present compared to university-based education, like MOOCs are helping much better educational system to gain knowledge. So when it comes to career achievement uh, of these, with the help of MOOCs and NPTEL courses, so more number of students, more number of faculties, and more number of other departmental area people, like they're expressing that they're enhancing with the career skills. They are acquiring careers like skills regarding their upliftment of their careers. Along with, because of this joining to the courses, they are, along with this, they are also adding additional courses, additional skills, like their soft skills procedures has been improved, their language expression, and their knowledge has been, they are gained with the knowledge, and they build with the confidence, they hold a good confidence at the time of expression. And at the time of, especially when it comes to teachers, they're like their presentation, the like, because of huge knowledge, acquisition of huge knowledge, their expression, whenever they go to classes, they feel that they are carrying huge plenty of resources, plenty of information to be delivered to the students. This is the major criteria which has been being given by these uh, survey faculty members as well as the students. So here, the study shows us that more number of like the students, like like whatever the survey which is being made with the help of students and faculty, each and every member who is like who has been answered this questionnaire, their personal view is like they have gained generally we say handful knowledge, so they have gained handful knowledge, they built an ability with their careers, with their knowledge, with their skills, with including soft skills, and which has made them to build their personalities. So and the one more criteria is, when it comes to MOOCs and NPTELs, these are most preferable and affordable to the students as well as to the faculties generally. And this is when like most of the colleges, they are like preferring to the giving an opportunity to the students whenever students who are clearing these MOOCs examinations, obviously they are going to fees paid by them. And
Ma'am, excuse me, ma'am. Your time up, ma'am. I've taken more than 10 minutes.
yeah, ma'am. Yeah.
Kindly make it fast.
Ma'am, just a minute. And when it comes to, like, it is for all sorts of learning. Like I hope, like in even in schools, these courses to be introduced for like there are plenty of schools which is going with international syllabus and ICSE syllabus, where they have an add-on courses like NEET, JET. And when these NPTEL courses will help to the students for their holistic development. Hello, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you so much. Panel members will take over the session.
So can I ask a question? Hello? Can you hear me? Hello?
Hello, sir. Yeah, sir. Yes.
Can you hear me? Yeah. So my question
Yeah,
is,
sir.
your conclusion is based on a poor statistics. So
Yeah,
do you
sir.
think this conclusion is going to change when you increase the statistics?
Sorry, sir. Can you repeat the question?
No, your conclusion is based on a very poor statistics, na? So is it going
Yeah,
to
sir. Yeah.
change? Is it going to
Yeah,
change?
sir. Yeah, sir. Definitely. the thing is, like when we were surveying first, like we inquired with the students, we didn't had a criteria of making a statistical report. So but when we started inquiring with the students, a number of students of past 2 years, like students were giving their overviews, what is the thing, like how many courses they have come across, how many subjects they are being added to their knowledge skills for their self upgradations. So because of that, like as this is we have like took most probably second year and final year students. So
No,
because of these
agreed. Your statistics in 2024 is based only on some 1,000 students, right?
yes sir.
So, have you surveyed all the colleges or schools in a area? Or what is the criteria? Because 1,000 is a very so small number, no?
Sir, like this is my first paper. So I went regarding like any minimum based of information,
Okay.
and we are confined only to the existing organization, Nagarjuna College of Institutions.
Okay, this is only within Nagarjuna College.
Yeah, sir. This is only regarding our college.
So what is the strength of the college? What is the typical strength of your college?
Sir, nearing to 1,000.
Oh, 2,000.
1,000.
That means you have surveyed your complete college, all the students.
Yeah, sir. Sir, like if I include even in engineering students, NGI, it comes to approximately 1,800.
Okay, that means you have surveyed most of the students.
Yeah, sir.
But the success rate is very poor now. What could be the possible reasons?
So because of their unconditional terms, like they have, like most of the times when it comes to NPTEL courses and MOOCs, obviously these exams are being conducted at the time of their examinations.
Okay, fine.
That is the major criteria. Because of that criteria, they couldn't register.
Fine. Okay. So
That is the major drawback of this.
what is the most sought out course in NPTEL?
Sorry, sir.
What is the most sought out course?
Like when it comes to engineering, it is like a CA based, computer applications and
Okay.
AI based. Most of the engineering students are going to opt AI, artificial intelligence, computerized techniques. When it comes to commerce and management, like they are preferring marketing, human resource, and psychological study, which is being based behavior of a person, like organizational behaviors. This is the being major courses which is being opted by the commerce students. When it comes to science students like BScs and BCA, they are going with their own core subjects. BScs, they went with like physics, related to physics and chemistry. When it comes to BCA, computerized applications and computerized applications in AI. So
So
most of the courses
what is the
opted by
final
artificial.
conclusion? Whether it is helping students or how much it is helping students? What is the final say on this?
Sir, like major students who are being opted these courses are they are highly motivated.
No, it's not motivated. Employability. Are they getting more employment?
Yes, sir. They are like their employability is more is been increased compared to last year's.
Okay, thanks. Man.
Thank you, sir.
Yes, it's a good presentation, and I think the NPTEL exam is currently being conducted at various centers. I have one question. What
Yeah, ma'am.
suggestions or what improvements would you suggest to make NPTEL courses more effective for learners? Your suggestions or improvements?
Ma'am, as what according to my survey, the NPTEL courses generally they are adding what is like according to the current scenarios. Whatever the like existing market is prevailed in global economy. So what are the
Okay.
changes it is being taken place? Those changes are being added to these courses every year. Like compared to last year, this year they have been upgraded with the syllabus.
In every year, you suggest
They
to
are
upgrade their syllabus.
yes. when it comes to students, there is a lot of changes, like technical changes, social changes, and research. And when it comes to research and development, there are plenty of changes. It is being taken place in the global market as well as in the current market. So if we keep on matching with these scenarios, with these NPTEL courses, obviously it may help n number of students to cope up with their jobs and professions.
Okay. Do you believe that such online platforms truly provide equal learning opportunities to all students?
Ma'am, definitely. When I can see the scenario of my own college, where I'm working on the base of my survey, literally, I justified few students. I categorized few students. Those few students, they are like their expression of viewers, ma'am, it is like high standardized compared to our university syllabus. Like few present learners, like first year students, they have been choose few subjects like according to their own class subjects. What is UGC criteria? On the base of UGC criteria, they have been chosen few subjects. So on the base of that, like their expression of viewers, like whatever the information which is being in the given in the textbooks or in the emails, more than that information is given by these IITs and IIS. Like elaborative information is being gained. So my viewpoint is it is more helpful compared to the present university scale of syllabus.
Okay, thank you.
Okay, it was a nice presentation. Am I audible?
Yes, sir. Yes, sir.
Okay. In many of the universities, these NPTEL courses are mandatory. So, in such a scenario, the course outcomes are they when they apply these outcomes in their academic projects or in their employability. So, are they really applicable? Means, do students really use these opportunities?
Sir, but what is the 2 years criteria? What I've been scaled up. See, last time we had an company called EY. So EY Deloitte over here. So when we placed a few students' applications like resumes and all, when we updated their resumes and all, most preferable resumes were given importance to the additional courses. Like they checked NPTEL. If NPTEL, they were questioning to the students how many different courses is being implemented, like learned by you people, and what is the outcome of it.
Okay.
This was a output which was bought, and like most companies, they're like when generally when it comes to UG students, like UG students are going with the plain certifications, like no add-ons. So when they are added some NPTEL or MOOCs online courses, obviously they are asking is are you practiced with a one subject or multiple subjects? If you are practiced with the multiple subjects, what is the like they are raising the questions on the subjects which are being learned by them.
Okay, that is correct in the case if it is optional, but in some colleges that is mandatory. Then all the students have to at least 2 or 3 NPTEL courses.
Sir, where I'm working right now in Nagarjuna, also NPTEL is a mandatory for students and faculties.
Okay.
Hello, sir.
Yeah, tell me.
Yeah, sir. Like plenty of the organizations, like I see that they made this NPTEL is a mandatory. In where I'm working right now, this is even in this college, NPTEL is a mandatory for even for learners as well as to the working people.
Okay. Okay, thank you.
Thank you, ma'am. Thank you so much. Any
Thank you.
other participants are waiting to present?
Yes, ma'am. NS 129.
NS 129. Okay, ma'am.
Yes, ma'am.
You share your presentation, ma'am. Panel members
Okay, ma'am. Thank
129,
you.
NS 129.
Ma'am, is it visible?
Yes, ma'am, it's visible.
Thank you.
Yeah.
Good afternoon to all. I am Aradi Bhaskaran, working in Vishwajyoti College of Engineering and Technology, Vadakulam. Our topic is exploring quantum computing, pioneering innovations for space research and sustainable futures. The research in space science is at the leading edge of humanity's endeavors to investigate the universe. However, it faces computational difficulties that traditional computing cannot adequately address. The intrinsic nature of tasks such as optimizing interplanetary quantum gravitational effects frequently surpasses the ability of the most sophisticated supercomputers. The review paper aims to quantum computing in space research, used to solve complex problems beyond the reach of classical computers. The technique used in quantum computing are quantum key distribution, quantum entanglement, quantum clock, and quantum sensors. The quantum key distribution is a secure communication method that utilizes the quantum mechanism to generate and distribute secret keys. It relies on the principles of quantum physics to ensure that any eavesdropping attempt will be detectable. Next, the key point is quantum entanglement. It's a phenomenon where two or more particles become interconnected in such a way that the state of one particle is instantly influences the state of others, regardless of the distance separating them. This is a spooky action at a distance, as Einstein famously called. It is a fundamental aspect of the quantum mechanism. Next, the another point is quantum clock. Quantum clock is a atomic clock that leverages quantum mechanisms for extreme precision in timekeeping. These clocks are often optical atomic clocks, using lasers to interact with atoms and measures the frequencies of their transitions, resulting in far. Next, the quantum sensors. Quantum sensors use the principles of quantum mechanics to make exceptionally precise and versatile measurements, offering significant improvements over traditional sensors. These sensors can detect subtypal changes in various physical quantities, including time, temperature, distance, gravity, and electromagnetic fields. Next, the combining geospatial analysis with the quantum computing for handling massive space data sets. The core principles of quantum computing are superposition, entanglement, quantum interference, quantum gate, and no cloning theorem. The superposition means in the classical computers, we are using bits, that is either 1 or 0. But in the case of quantum computing, we are using qubits, that is it can act in both the 1 and 0 state. That is a superposition state. Next, the entanglement means the state of one qubit can determine the state of another qubit. That is the major advantage of entanglement. Then quantum interference. Next, quantum gates. Quantum gates is similar to our logical gates, but it can predict more precise states. And the no cloning theorem. No cloning theorem help us to prevent the eavesdropping, because the current state cannot be predicted or it cannot be reversed. Early research has highlighted various essential elements that affect the incorporation of quantum computing into research exploration. These elements include technical obstacles, environmental factors, and necessity for tailored infrastructure. The main elements are radiation, cooling systems, quantum algorithms, and error detection. The radiation effects on quantum hardware. The impact of radiation on hardware is considerable, as the extreme radiation conditions in space present notifiable difficulties. High energy particles originating from solar flares and cosmic rays can interfere with cubic states, resulting in inaccuracies in quantum calculations. Current studies indicate that even minimal exposure to ionizing radiation can diminish the qubit coherence times, thereby compromising the dependability of quantum systems deployed in space. To address these challenges, scientists are investigating the use of radiation resistant materials and specialized error correction methods designed for applications in space. Next is the cryogenic cooling systems. Cryogenic cooling systems are essential for the effective operation of quantum computers, which typically necessitate very low temperatures. The deployment of cooling systems in space presents significant challenges related to weight, power consumption, and thermal management. Research has underscored of developing compact and efficient cooling solutions, including closed loop systems and innovative insulation materials to ensure that quantum hardware can function optimally in space. Quantum algorithms for space research. Quantum algorithms in space exploration. Quantum algorithms possess the ability to transform space research by facilitating simulations and analyses that exceed the limitations of traditional computers. For example, the quantum approximate optimization algorithm has been investigated for planning spacecraft trajectories where the quantum k-means algorithm demonstrate potential in handling extensive data sets obtained from space missions. The implementation of these algorithms could greatly improve data processing and decision making in the realm of space exploration. Quantum communication and security. Quantum communication and security, quantum distribution, quantum key distribution, QKD, provides a secure communication method by identifying eavesdropping attempts via quantum entanglement. Research has shown that QKD is viable in space, with the successful experiments demonstrating satellite-based transmissions of quantum signals over extensive distances. Error correlation, quantum error correction for satellite communication. NISQ era introduced significant challenges stemming from errors and noise inherent in quantum hardware. The application of quantum error correction codes, including surface codes and shore codes, is essential for preserving the integrity of signals utilized in satellite communication. Research highlights the critical role of these methodologies in guaranteeing dependable data transmission with a space-based quantum systems. Combining geospatial analytics with quantum computing. The integration of the geospatial analysis in space research seeks to address the constraints of traditional computing in handling the growing volume and intricacy of spatial data. Improved management of extensive geospatial data, quantum speedup, optimized machine learning, enhanced data integration, quantum optimization, real-time geospatial analysis for essential applications. The research explored the use of quantum computing algorithms on three major areas in space exploration: optimization of orbital mechanics, deep space communication, and extraterrestrial material analysis. In space science, quantum algorithms such as the quantum approximate optimization algorithm and variational quantum Eisenhower are being adapted to solve optimization and simulation tasks. Quantum optimization for trajectory planning. We applied a quantum approximate optimization algorithm for multi-body trajectory optimization. In comparison to classical simulated annealing, QUOA reduced computational time for trajectory solutions with the 5 gravitational bodies by up to 37%. For small-scale models, less than 10 variables, quantum solutions were almost identical to classical result, with a deviation of less than 2% in their path efficiency. Quantum communication protocol simulations. The entanglement-based model of communication, we have simulated the fidelity of quantum key distribution in simulated Earth, Moon, and Earth Mars distances. Simulations gave us an average fidelity of 91.2% for Earth Moon communication and 83.5% for Earth Mars under idealized noise conditions. This indicates feasibility in secure quantum communication over planetary distances with the suitable error correction protocols. Quantum machine learning for spectral analysis. A quantum classifier that attained an average accuracy of 94.8% performed better than classical SVMs by as much as 6% over the same data set. VQC also displayed insensitivity to data imbalance and noise, representing a potential method for real-time in situ analysis during mission travel. Limitations and sensitivity to noise. Simulations on noisy intermediate scale quantum hardware demonstrated high sensitivity to decoherence and gate errors. Solution quality deteriorated by 15 to 25% for QAOA circuits larger than 20 qubits. These results highlight the necessity of error mitigation techniques and the need for hardware improvements to fully achieve quantum benefits in space missions. And our conclusion is that quantum computing is a new type of computing that uses the laws of quantum physics to process information in a fundamentally different way from traditional or classical computers. Thank you.
Thank you, ma'am. Panel members will ask the questions now.
So just for curiosity, has any of the space
Yes, sir.
agencies are you aware of any space agency that has implemented any of these quantum computing technologies in their space missions?
I yes, NASA is using this.
For what purpose? For what
NASA
trajectory?
is sir for space related space related researches. NASA is trying to use, or it is in the it is in a basic condition to use quantum computing for the space related researches
No, no,
by
no.
NASA.
My question is it implemented? Has NASA implemented quantum computing in any activities in the space mission? That's my question. I'm not aware, so I'm just asking. If they have
Okay, sir. I
implemented,
am not sure
as
about that.
they have implemented, yes.
I'm not sure that, sir.
Okay, okay. But you mentioned about certain difficulties such as radiation effects, etc.
Yes, sir. Yes, yes,
My
yes.
question is, can't certain shielding material be designed so that the effect of radiation can be minimized?
Yes, sir. They are trying to, or the researchers are trying to develop radiation resistant materials for the for this purpose.
So the last question
Nowadays,
is,
it's a yes, sir.
the last question is how effective quantum computing is in communicating satellites compared to the way what they are doing now.
Sir, quantum computing is very fast. The classical computers can only calculate very
No, no,
small amount of data. But in
I'm
the
not
case
talking
of
computing. No, 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 no. I'm not talking about computing. In communicating with the satellite from ground.
Oh, sir. Yes, we can communicate from the ground. That is, no one can eavesdropping or no one can hack our communication in the case of quantum computing.
Okay. Okay, thanks.
Okay, sir. Thank you.
But one question. Have any one last
Yes, sir.
question is have
Yes.
any of the space agencies implemented
Yes, sir.
communicating with the satellite using quantum computing methods?
Sir, I think NASA has implemented, but I am not sure about that. I
Okay.
thought I read it, but I forgot.
Oh, fine.
Okay. Am I audible?
Okay. Yes, sir.
Hello.
Yes.
Okay, okay.
Yes, yes.
In what ways can quantum computing contribute to sustainability efforts through space research?
For space research, we can use quantum computing for communication with interplanetary communications. We can use this quantum computing. It is very sustainable because large or massive data can be um, computing.
Okay, then what is the role of then what role do quantum computing algorithms play in optimizing space missions?
Mm, so, um,
Okay, no problem. Thank you.
okay. Okay, thank you, sir.
Okay, it's good presentation. I have only one question. Then, how we
Yes,
can
ma'am.
make sure how we can make sure quantum system works well in space condition?
Ma'am, once again, please.
How we can make sure quantum system works
Yes.
well in space condition? Is it audible?
Mm, yes, ma'am, audible.
Did you get my question?
The quantum, no, ma'am.
My question is how we can make sure quantum systems works well in space conditions.
Mm,
So can quantum computers sustain the space radiation effects, vibration, thermal effects? Can
yes,
it
sir.
sustain? Can it sustain?
Yes. Yes. At least, at most of the extent, it can sustain. But as the radiation increases or it cross across a limit, then it cannot sustain. The quantum hardware is the main limitation of the quantum computing.
Okay, thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you so much. And any other participants are there to present?
Yes, ma'am. I am Bindu.
Yes, ma'am. Your
My
paper
number
ID,
is
ma'am?
107.
107. Yes,
Yes,
ma'am.
ma'am.
Okay, ma'am. You can proceed.
Ma'am, is the paper is visible?
Yes, ma'am. It's visible now.
So good afternoon, everyone. Myself, I am Bindu, Assistant Professor in Department of Commerce and Management from Nagarjuna College of Management Studies from Chikballapur. So today I am discussing a concept regarding to the banks as a catalyst in empowering SMEs growth in India. So just I thought to write a paper regarding to the information of a SMEs. Why I have concentrate the SMEs means it is one of a part of our Make in India project. Our central government is concentrating on developing all the kinds of a traditional kinds of a things, like it may be a khadi production or the core industries or honey productions, like these kinds of a things means these are all the traditional kinds of a business. We are focused on that to empower them. We have made a n number of a kinds of a things for development. When it comes to the history of a MSMEs means it is a medium small scale industry, sorry, micro small and medium entrepreneurs. It was initially established in the year of 1991. So the ministries of small scale industry and the agro and the rural industries, they have created this project. Later on in the year of 2001, they have got separated. So Ministry of Small Scale Industries, they have looked towards the development of a small scale, and Ministry of Agro and the Rural Industries, they have concentrate on development of the agriculture and the rural industries. So after the years passed on, in the year of 2007, again the two ministries, they were merged and they were renamed it as a Ministry of Micro, Small and Medium Enterprises. So the major changes was happened due to the updates in the Government of India rules and regulations of 1961. So the objective of a MSME means the Ministry of a Government is to promote the development and growth of MSMEs, including Khadi, village development activity and core industries. And also we are concentrating on to increase or create a new enterprises among the youth in our country. So especially the small and medium enterprises, right now it is a backbone to our country. Why it is a backbone means 45% of our GDP income has been raised from these kinds of sector. So especially when it comes to means MSME has been divided into a multiple parts. So here if you are going to be look after here, micro enterprises we have. So micro enterprises is nothing but, so those investment is up to the 1 crore. 1 crore investment people will come under the micro enterprises and their annual turnover will be 5 crore. And the small enterprises, their investment will be up to 10 crore and the annual turnover will be greater or lesser than the 50 crore. And medium enterprises, their investment will be 50 crores and their turnover will be 250 crores. So then the objective of my study is to examine the role of formal and informal financial institutions in meeting the credit needs of SMEs across various stages of their business life cycle in India. Why I kept the objective of my study this point means, nowadays, the financial institutions, without the collateral securities, they are not providing any kinds of a loan facilities to the normal people. If any of a youth, he won't willing to make a establishment of any of a business or something, they need to be submit the some of the securities. Secured securities, they need to be pledged or mortgage, and they need to be borrow a loan from the financial institution. To overcome from these kinds of difficulties, the central government has announced n number of schemes. That schemes I am going to be discussed later. And to evaluate the effectiveness of a government schemes and initiatives. So normally, the government has provided the n number of facilities to the youths of our country to start their traditional business or to come up with the new ideas to start up the entrepreneurs in our country. So how the government schemes are getting effectiveness, I need to be look after that one in this paper, and to expand into a domestic to the global market. Even though our MSMEs, they are the micro in the size, on small in the size, and even though in the medium in the size, they are also looking forward to the opportunities of a global market. And it contributes to the employment generation and GDP growth. Even the SMEs, around 45% of a GDP percentage has been contributed by those kinds of sectors. If you are going to be looked after to the contribution of SMEs to our Indian country, just I referred only the 4 years past information. So GDP and the output, SMEs contributes approximately 30 to 35% of India's GDP. But right now, the current update is 45% of a contribution is there from the our countryside through the SMEs. When it comes to the 1920, 30.48% of a share of income has been contributed by the SMEs. 2021, 27.24 has been contributed. 21-22, 29.15, 22-23, 30.10. So we have, if you are going to be look after to the slide, you can observe that when we have decreased in the year of 2021, 21-22 due to the impact of the COVID. None of our schemes have been worked properly and we are not able to serve also. When it comes to the employment, according to the Ministry of Micro, Small and Medium Enterprises, there are over 63 millions of persons have employed. These enterprises employ over 113 million people, which is about 40% of our country's workforce, and also contributes about 30% of India's GDP. And especially from the manufacturing output, we are receiving a 45% of GDP. And increasing export, obviously the SMEs has been increased their export. If you are going to be look after to the chart I have provided, the same thing has been affected here also. At the time of COVID, we couldn't able to reach our target, but when it comes to the year of 22-23, it has been increased to 43.09.
Excuse me, Bindu ma'am.
Yes, ma'am.
Last 1 minute left, ma'am.
Ma'am?
Bindu ma'am. Last 1 minute left, ma'am. Kindly finish it fast. Last 1 minute left, ma'am.
Okay, ma'am.
Am I audible to you, ma'am?
Yes, ma'am. You are audible to me.
Ma'am, last 1 minute left. Conclude fast.
Yes, ma'am. So even though I have concentrated on the methodology I have received from the n number of publications. I have done only the secondary data collection. I have go through with the collection of data through the authenticated website along with the research panels, research gates and everything I have collected. When it comes to the challenges of my study, an individual person who is willing to take a loan from the any kind of a government scheme, it is difficulty to them to take a loan procedure, approval thing and the procedures of high rate of interest, everything it is going to be get delay. And due to the unstable cash flows and the market risk, the SMEs is unable to get their loans. The suggestions I have given here means streamlining the procedure to reduce the bureaucratic delays. So my suggestion is to reduce the barricades regarding to the application of a loan and promoting unsecured lending. And even though my suggestion to promote unsecured lending, right now it is happening. The government of India only took over the initiation and they are providing the certain crores of amount to the public who are willing to start the enterprises without pledging of any securities. Targeted financial education initiation. So we need to be provide the different kinds of schemes which are available under the central government to the public who are willing to start their business. And also we are developing the hybrid funding models that combine traditional lending with the innovative digital financing solutions. Even though the SME is also moving towards the digital transformation of era, they are also using the concept of fin technology, where everything will be through the digitalization, the fund transferring, everything will be through the digitalization itself. It's my paper. Thank you for giving this opportunity.
Thank you, ma'am. Chair just will ask the question.
So, madam, just one question. Do you suggest that current funding is inappropriate is not conducive for SMEs?
Sir?
Do you suggest that the current funding by the banks are not conducive for SME growth?
So right now, recent budget, they have funded a lot of amount for the development of SMEs.
Okay.
Previously, when it matters to me, the previous information, Funding is there, but when it comes to the taking a loan from the banks or the financial institution, lots of a verification and delays are there. But right now, those kinds of a barrigation is getting little bit liberal. But still, while seeking to apply for the any kind of application, some of the difficulties is there and delay of the process is there, sir.
So, what is your suggestion to improve this?
Suggestions to improve this means just before funding anything, they are going to be collect the business plan and right now the central government also they are offering a unsecured loan facilities also, means without pledging any kind of a things, they are providing a loan facilities to the certain youth people. Up to 50 lakhs we are getting a loan for the manufacturing industry along with the subsidy. So those kinds of information we need to be deliver, or we need to be provide the certain financial educations to the concerned person.
Thanks, boss.
But right now it has been liberalized, sir. The current era, applying for the funding and financial through the financial institution, everything is liberalized. Through the Udayam registration portal, we can register, sir. It was implemented in the year of 2022.
Okay, do you think that the current financial schemes are sufficient to meet the growing needs of MSMEs?
Sir? Hello, sir, I'm not audible.
Do you think the current financial schemes are... Am I audible?
The current... yes, sir.
Do you think the current financial schemes are sufficient to meet the growing needs of MSMEs?
So right now it is in the process of growing only, sir. When it comes to the micro enterprises, 95.11% of total increase is there. And when it comes to the small scale also, there is a huge of increases. What the funding they have provided right now in the budget, if youths or the persons who are willing to take support from the central government, if they properly used, means always there is a growth in the GDP. Because right now through the SMEs only we have a income of 6.3 crores.
Okay, thank you.
And the another thing, so totally we have an enlarged number, means more than 7 crores of SMEs has been established till right now in our country, sir.
Okay.
I have one question.
Yes, ma'am.
To what extent, to what extent does the lack of financial literacy among SME owners hinder the effectiveness of banking services?
Ma'am, tell me once again, ma'am.
They are not that much literate. To what extent the lack of financial literacy among SME owners hinder the effectiveness or prevent the effectiveness of banking services?
Ma'am, you are asking about the literacy?
Yeah.
Ma'am, we are not going to be bothered about the education and all, ma'am. Ma'am?
Excuse me?
Lack of
financial literacy among SME owners.
Lack of financial literacy.
Yeah.
Okay, sir. Ma'am, when it comes to the financial literacy, right now the central government only they are providing a n number of rules and regulations, and they are guiding, ma'am. Sessions are conducting regarding to the SMEs. When it comes, if you are going to be go through with the certain websites, you can get the entire information. If a government is going to be take an initiation of a volunteer, that volunteers can deliver the thing. For example, in our college, what we are doing means we are tagging up with the bank. So in our college, with the students along with the bank, we are reaching out to the some of the villages, and we are reaching out to the small enterprises, and we are educating them regarding to the financial awareness. What kind of a facility? For example, if a woman who is going to be take a loan, for her there is a subsidy. And categories belongs to SC, ST. If they are going to be take a loan, there is a subsidy. Like how much percentage means, if you are going to be take a 50 lakh rupees of a loan, 15 to 30% of a subsidy will be provided to this major three categories. So these kinds of things we are going to be provide the creation of awareness to the all the persons, ma'am.
Okay. First to educate themselves and to provide all these facilities.
Yes, ma'am. We are doing in our college itself, ma'am, as like an
Okay,
outreach
okay.
program.
Okay, thank you.
Thanks a lot, ma'am.
Thank you, ma'am. Thank you, ma'am. Is any other participant
Thank
left out? No, I don't think so. We are
Done, I think.
I think that it's done, sir.
Mhm.
So we have lost the opportunity.
Yes. One not one joined, but left.
Yes, sir. There is a network.
Yes. So I think it's done.
Yes, sir.
Right, sure.
Can you sign this?
Aisha has left. I hope it's done, I think.
Yes, sir. Because we are having some issues on it.
Okay.
Dates.
Date. So what is it?
Three,
Third
sir.
one.
3, 5.
You can close now. I can log out.
Yes, sir. We have lunch.
Okay.
Because already it's
No, it's okay. Log out.
Hello. Vaishak sir, am I audible?
Hello, ma'am. Can I leave from this meeting? Hello? Hello? Hello?
Hello.
Can I leave from this meeting?
Uh, Hello, am I audible? Hello, ma'am, am I audible?
Yes.
So I especially extend my heartfelt gratitude to Dr. Stalin, Dr. Jitu Matthew, and Dr. Bindu George for graciously serving judges for this event. Thank you so much, ma'am.
வீடியோ எடுக்கணுமா அது ட்ரைபாட் வேணும்
இந்த தலைக்கு மேலே எடுக்கணும் சார்
not damage to environment and using cosmic energies.
This one.
Provide some solution for it. Okay, you have to find out something and provide a solution. This is the need of the hour. So I can give a solution. This can be the solution for whatever is needed. Okay, and you have given some future work as quantum computing, data-driven AI. It's not future work, it's the current trend. Quantum computing is the current trend. It's not the future. AI is already, it has gone to now. The AI is, they have gone to operator AI. Okay, they've gone to the next level. Next level of AI. Those are all not considered.
It is alternative lower energy, sir. And the AI drive can energy optimize.
You are talking about big data analysis. What is big data? Data means what? Raw material. Okay. You have first year physics. Huh? BCA students. Nice, very good. I really appreciate your initiative because being the first year, you may not be having a knowledge of what exactly seminar is, what has to be done. Nice, I really appreciate. Very good. Okay, but please do some cross check what exactly what has to be done. Try to find out what it is. Participate. First you participate, you will get it. Good.
The next participant is NS 121.
Good afternoon, everyone. I'm Teja, and I'm from Department of Science, pursuing my third year. I'm going to present about an interesting topic: revolutionizing space and sustainability with quantum computing, under the theme of sustainable computing and cosmic innovations. So, in this presentation, we'll be seeing how quantum computing can be used in the transformation of space and sustainability. The next slide, please. For that, first let me tell what is quantum computing. It is a new kind of computing that uses the principles of quantum mechanics. And quantum mechanics is a science that explains the behavior of atoms. So we'll make use of the principles of quantum mechanics and we'll try to make our tasks much easier. So that thing is done by quantum computing. What is the difference between regular computers and quantum computers? We know that computers understand binary language and data is stored in the form of zeros and ones. So, in quantum computers, what happens is it will make use of qubits. Qubits is zeros, ones, and sometimes it can make use of both. Both in the sense, this is what called superposition. Superposition, it tries to take out the possibilities of everything. I'll give an example for this. For example, when we have to find the best solution out of consider some 1,000 possibilities. So what regular computer does is it will take out each possibility and it will check whether it's the best or not. But when it comes to quantum computers, it will examine all the 1,000 possibilities at a single time. And this is the biggest advantage of quantum computers. That is how the quantum computers give an advantage in solving complex problems and make our tasks handle more easier that the regular computers find it impossible. The next one. So there are many applications for quantum computer. Like we can make use in cybersecurity, in quantum encryption, and in finding oil and gas exploration. Even in logistics, we can make use of quantum computers to find the best delivery route. So in this presentation, we'll be discussing about two main applications. One is space research and another one is sustainability. First, quantum computing in space. First thing, satellite communication. We live a lot of satellites from Earth, and the main objective of a satellite is it should give us data, it should give us information. So we can make use of the quantum computing so that the data from satellites, the information that the satellites get, we will receive it in a more faster and secure way than ever possible. So that we can make use of quantum computing and navigation and positioning. Even the GPS or Google Maps, when we have to get the exact or the most precise and accurate location, this quantum computer helps it find it very much better. And space weather prediction. When it comes to space weather prediction, it can be like sometimes there will be magnetic radiations from sun or cosmic radiations, and there are chances for the different things. So for that prediction, so that we can ensure the space mission is successful, to ensure that we have to predict how the space weather is. So for this, even the quantum computing can be very much beneficial. And Earth and space observation. Earth and space observation is we have to observe the whatever happening in space, and even we should get the data about what is happening in the space too and what is happening in the Earth. So everything can be observed more precisely and more better in the quantum computing thing. The next. Simulating the cosmos. First, let me tell what is cosmos. Cosmos is something that is in the space. It can be anything in the universe. Everything comes under cosmos. And what is simulation? Simulation is making something virtual that exists in the real world. So why do we have to simulate things? We need to simulate because we have to predict and analyze what is happening. Its formation or its working, its behavior. We have to study all those. And that is the purpose why we simulate things. So this simulation of cosmos can be very complex thing, but equally it is important too. So quantum computers can perform many calculations at once. As I already told, because of its ability of the superposition principle that comes under quantum mechanics, this quantum computers, it can perform many calculations at once, and therefore it can solve complex problems. And here is a graph. The previous. This is a graph that shows how quantum computing can impact on space research. There we can check out the blue color thing is classical computing, the normal computing, and the orange is quantum computing. For the simulation accuracy, the levels in all three, even the simulation accuracy, weather prediction speed, and trajectory optimization. This trajectory optimization is finding the best and the shortest route possible for a spacecraft or a satellite to reach. So all these things are very much more better when we can make use of quantum computing. That is the analysis of the graph. The next. Space mission optimization. If we have to launch a space mission, we definitely have to consider a lot of parameters. Like we have to consider the fuel usage, orbital path, the payload capacity. We have to consider many things. So it involves solving very tough problems. So quantum computers can do this task much faster and more accurately. It will make use of quantum algorithms so that it can analyze thousands of plans very quickly. And we can find the shortest, best path and the paths which are low risk and cost. So that is what an ideal space mission optimization is. The next. Now we'll look into sustainability. We all have heard of the term what is sustainability. It is we have to use the resources concerning the needs of the future generations. So how we can make use of, we know that quantum computing is an emerging technology. How can we integrate quantum computing with sustainability? This is what we look here. The potential impact of quantum computing on sustainability. If you look into that donut chart, it is 29% for efficient climate monitoring. We can make use of quantum computing up to 29% for the climate monitoring itself. We know that climate of the earth keeps changing and we have to consider temperature, ocean currents, all these things. We have to consider so many things. So for these things we can make use of quantum computing and reduce space mission waste. If we know the shortest and the best route possible, in that way we can lower the fuel usage, and if we lower the fuel usage, even the mission waste will get reduced. So in this way it will even help in reducing space mission waste, green space infrastructure. We anyhow need lot of data from the space, and so we need satellites. But we should ensure with the usage of quantum computing, we should ensure that we can do the things that are eco-friendly. That is green space infrastructure. That when we can use up to 20%, and resource mapping and conservation. When it comes to resource mapping, it is like finding the resources. Where is ocean currents, or ocean resources, natural resources, forest, air, all these resources, if we find properly, we can make use of that properly. And solar energy harvesting. We can make use of quantum computing in the solar panels. That will help conserve lot of it will capture a lot of solar energy and it will last for a longer time. So in that way we can make use of it. Environmental monitoring. Environmental monitoring tracks Earth's ecosystems, weather, oceans, forests and air. So we'll get a lot of data from the satellites. Handling this data will be very difficult for a normal computer because its processing thing might be slow. So when we can make use of quantum computers, it can process huge amounts of data faster, because of which we can find patterns, detect changes and make better predictions. The next. Smart energy systems. What is smart energy system? It is producing and managing energy using the modern technologies. So that is smart energy system, and here the modern technology we are talking about is quantum computing. So it helps to make quantum computing more smarter. We can make use of renewable energy sources and integrate it with computing technologies, and that will help develop smarter energy grid. Smarter energy grid, it will help to balance about the distribution, usage and the consumption of the energy resources. Quantum computers improves the speed and accuracy of decisions. So if we can analyze multiple data streams very quickly, we can easily improve the speed and accuracy of the decisions. The next. Climate modeling. Scientists use climate models to predict future changes. We know that climate keeps changing every time, and we have to take into consideration lot of variables. As I mentioned, wind pressure, temperature, Earth's ocean currents, everything. All those things.
Like the users control system is more efficient, faster extractions of resources. Next, seeing users manipulate streets for with national containers for storing servers inside and accessing data powered by renewable resources like wind, tidal and solar energies. Users
any other cosmos that's present in the universe, and it will help to improve predictions of space weather. So that improvisation can happen through quantum computing, and planning trips to Mars and Moon will be easier. Like if you have to conduct space missions to Mars and Moon, that process will get more easier when we can make use of quantum computing. Future scope and sustainability. So in sustainability, what can it have in future? It could change how we generate and use energy. Right now, we are using some of the energy resources, but in the future, there are chances that we can change how we generate and use the energy. More efficient renewable systems. With the use of quantum computing, we can make more efficient renewable systems. We can make use of turbine technology, or we can make use of the solar panels, and new batteries for batteries and pollution control could be discovered. So we can invent batteries that can stay for longer time with easy managing things. Climate models will become more detailed. So we can have the climate models that are more detailed, and this will help the experts and leaders make smarter choices. The path forward. Despite all things, what are the things we need to do to make the journey of quantum computing better? First thing, we have to build stable, scalable quantum computers at lower cost. We have seen that cost is a limitation. So we have to ensure that it is being scalable and it is stable, and it also is at low cost available. Then solving these problems will require teamwork. Every activity requires teamwork, so even this does. As the technology is developing, it will start becoming more useful. So we should try to develop it, and it offers powerful tools to address bigger problems. It is a very powerful technology that will make use to solve very big problems. The next conclusion. Quantum computing has a potential to change how we study space and protect our planet. It has the capability to solve complex problems and much faster, more precisely than what today computers does. So this opens a new door even to the technology thing, even to the greener energy and technical ideas. It will help us simulate stars, planets, improve energy use, at the same time predict climate changes. So in this way, we can make use of quantum computing technology to have a smarter and a greener future. Thank you. Yes, sir. I wasn't aware of the fact that I have to add references. I added it in my paper, but I didn't know what I had added. Maybe. Okay, so next time.
It's a new one only, no? Quantum computing.
Yes, ma'am.
You have done research in that?
Yes, ma'am. This is the very first time I even started getting a little knowledge of what quantum computing is. Before this,
what research you have done in that quantum computing?
I came to know about how the quantum computers. Yes.
What was the paper you have referred? You said that you have done it included in the paper. Okay, you have written as a paper. Have you written as a paper?
No, ma'am. I referred so many papers and then I did a paper.
Okay, see, my understanding from your presentation is the conference is about you have to give a solution for sustainable computing. Okay, so can I take that you are suggesting that quantum computing can be
used in
are you suggesting that? That
Yes.
is what I was able to. I don't know. I'm just asking you.
Yes,
Okay.
ma'am. What I tried to mean is we can make use of quantum computing in the fields of sustainability and as well as space, and it is much more better than the regular computers we are using right now. That is my.
So that's what you were
What
trying
I
to
was
say from your
conveying, yes.
presentation. That's good. Really appreciate it.
Thank you.
So that being the case, have you referred any research articles?
Yes, ma'am,
You have referred.
Yes, ma'am.
Okay, do you remember anything? You can quote it now.
I do not I've researched on quantum computing in space, that being the title of the papers. So those papers I've referred a little.
So all those papers, all this, whatever you have taken, it is from there you have taken.
Yes, ma'am.
Do you have any review? It's a review paper. We call this a review paper. Okay, it's like you have taken, referred to so many paper, and you have reviewed what was the work that is carried on.
Yes.
That's what you have done.
Yes.
Good.
What level this quantum computing research is doing?
Any idea that quantum computing research is going on?
Quantum computing research is going on, like it is trying to be used in so many fields. It is trying to make our lives much better, but I'm not sure of how much level it has reached up to. But we are trying to implement it to almost all the technologies. Thank you.
The next participant is 34.
So, good afternoon everyone. So, I'm Navyashri from First PCA. This is Sirisha. So, we are presenting a presentation on space research and sustainability. So, as we go into deeply, quantum mechanism is basically based on the quantum mechanics such as superposition and entanglement. So, we we go through the normal computers these days, but normal computers are very not accurate based on the quantum computing. As we differ between normal computers and quantum computers is way more better than the normal computers.
Introduction. Quantum computers use superposition and entanglement, where superposition is a quantum bits, which are also known as qubits, 0 and 1, which are used at the same time. Entanglement, where we consider two particles which are connected to each other when they even stay far away. And they solve complex problems which could not be solved by the normal computers. And it designs a model for energy system using VQE, where VQE is a variational quantum engine solver. It uses this model consumes the energy, and it designs based on this.
So, as we go to the literature review, quantum computing for space mission data processing. As we know that quantum computing in space research, it will give us faster and more accurate answers than the normal computers. As we use the language of qubit digits in the quantum computing, it is way more better than the normal binary digits. So next, simulations for extreme environment. As the researchers are researching on the fundamental physics, we go through the quantum chromodynamics. For example, a scientist is researching on the chromodynamics. It governs the interaction between the subatomic particles. This is basically used to create black holes and neutron stars. Quantum communication, SEAQU, is space entanglement annealing quantum experiments. These are the experiments which are NASA funded, and these are developed in the international space stations to explore the overcome the challenges like radiation damages. Quantum computing also use the algorithms of Shor's algorithm, Grover's variable quantum entanglement. So these are algorithms used for solve the problems of cryptography, search optimization, space material simulations. Hybrid computing approaches for deep space missions, such as it combines both normal computers and quantum computers to get the more accurate and fast answers.
Methodology. Review quantum algorithm applications in space. It means it is the study of the quantum algorithms which can solve problems in space missions. Focused on hybrid quantum classical methods, where hybrid quantum classical models like hybrid is a combination of both quantum computer and a normal computer. These are used in the real projects like NASA and IBM. It is a study of quantum error mitigation techniques, where quantum computers are sensitive. So we need to study about how to fix and reduce the errors in quantum computing.
So, as we go through the results, optimize satellite communication and trajectory planning. So, based on the quantum computing, we enhance the efficiency of communication through the satellites and the trajectory plans to the orbits, simulated material behavior under space conditions, developed autonomous system using quantum machine learning, such as quantum supported variable, autonomous detection and error correcting, achieved improvement energy efficiency machine management, reduced operational costs and energy. As we use the quantum computing, it requires rare resources, so we need to reduce that to sustain the environment.
Sustainable development. Why sustainability is needed. Energy consumption. Quantum computers are basically stored in super cold temperatures because they contain qubits which loses their quantum materials when they are in the heat. So energy consumption is material scarcity. Quantum systems uses rare materials like niobium and silicon, special silicon like silicon 28. Overusage of these harms environment and cost also rises. Environmental footprints. By developing sustainable quantum computing, causes of environment is also reduced and energy consumption by quantum computers also is reduced.
So, why do we need the sustainability in the quantum computing? As we go through long-term scalability, sustainability quantum ensures that as we build a larger and more powerful quantum systems, they remain energy efficient and environmentally friendly. Innovative materials, sustainability drives research into alternative, abundant and eco-friendly materials such as those used in photonic quantum computing, which might reduce dependency on rare resources. Green applications, quantum computing itself can accelerate research into climate modeling, renewable energy systems, and carbon capture technologies, contributing to global sustainable goals. Lower operational costs. Energy efficient quantum system reduce the operations expenses, making quantum technologies more accessible and practicable for widespread use. By incorporating sustainability into quantum computing, we balance innovation with responsibility, ensuring that this transformative technology benefits humanity without overburdening our planets. So challenges and opportunities as we face. Challenges are we took basically two: quantum decoherence and noise. Basically, the decoherence is that where quantum computing faces temperature fluctuations and electromagnetic fields, which may differ in the environment. It changes the qubits digits as it transmits the data from ground network to the satellite. So we need to reduce that. And hardware limitations, short coherence times. Short coherence times, it means that it which occurs before the decoherence, and opportunities to reduce that. Secure quantum communication, real-time gravitational field sensing, sustainable and efficient machine designs, advanced climate modeling for Earth and Mars missions.
Conclusion. Quantum computers realization space research enables greener and smarter technologies, future focus, error correction, scalable quantum hardware, eco-friendly material research, expanding quantum research for planetary sustainability. These quantum computers are much faster and smarter ways than the basic computers. It is even eco-friendly, so it reduces harm to the environment. Thank you.
What are all the papers you people have referred, those references? If you read those papers, you just go to that reference. If you people refer that, all of first year BCA. So that means you should be having an idea about what is algorithm. You should be knowing what is meant by algorithm. You were mentioning about algorithms. I really appreciate it. Really. You need to have a base. Did you read them? No. You just took the name. Yeah, it didn't spark you. You have a mentor, you have a faculty mentor. All the physics paper, no faculty mentor. No faculty mentors are there for you. Nice, very good.
No, just as an audience. No, this is just like an audience. Okay, I am an audience fundamentally. So it's a review article is good, but you have written many things on the screen. Did you try to understand? No, for example, you mentioned about trajectory planning. What is that?
Path to, it's a path to where shortest distance.
Path to put the spacecraft, satellite. So why it needs quantum computers?
Because it is way more better than the normal computers.
Better means what? That's fine. Better means what?
It gives accurate and more speed outcomes for the
Speed is okay.
Okay.
I correct you.
Trying to make the people understand what it is.
Then you mentioned about neutron star and black holes.
Yes, sir.
What are they? Just I know not question, but since you must be curious to know what those objects are, right? What are they? I just try to.
Black hole is just where I think is that where thing it where the thing cannot be found if it's gone into the black hole.
That is okay, but what are these neutron stars?
Where atomic particles combine.
No, it's good, but anyway, you have learned a few things. But when you go up now, you try to understand what these objects are. You must be curious. That's what you think.
Yeah, yes.
These are nothing but the end stages of stars. Neutron stars, black holes.
Being a BCA student, algorithm
Yes.
should immediately get attracted. No? Being a BCA student.
Okay, good, fine. Just.
I kindly request all participants to maintain the decorum and alternatively engage the participants and kindly listen the judges what they are telling. Please kindly follow the decorum. Next participant is NS 135.
everyone, I'm Sharmila from 3rd BSc. So today I'm going to talk about the topic that connects the two powerful ideas, that is mathematics as a catalyst for sustainable innovation. Next slide please. So sustainability is the most important challenges that we face today. We are dealing with environmental challenges, limited resources and social inequality. It is clear that we need smart and practical solutions. So next we are coming to the mathematics. Mathematics is a theoretical subject, but here it is acting as a golden key to solve the sustainable problems. Next slide please. In this paper, we have worked with powerful tools, that is mathematical modeling, differential equation, optimization and linear programming. What is meant by mathematical modeling? Mathematical modeling is just representing the real-time problem into an equation. For example, climatic change, climatic changes. Then coming to the differential equation, it is the rate of change with respect to time is called as differential equation. Then we are coming to an optimization. Optimization, in simple we can say, it is the best way to do something is better. Then we are coming to the linear programming. It is the technique that we are using to take the decision correct manner. Next slide. Now we are going to use a real-time problem. That is, assume you are as a farmer. So you have harvested lot of vegetables that you need to store in particular storage, like we need to cool that vegetables. Here in this question, we'll take this as two scenarios. First scenario, it is the vegetable is at the room temperature of 25 degrees Celsius. We need to reduce it to 10 degrees Celsius. The storage room is about 5 degrees Celsius. So how much time it will be taking to cool? Next slide please. Using Newton's law of cooling, the first equation, we will be solving and getting the second equation. Then with the given temperature, that is the initial temperature is 25 degree and we need to consider 5 degrees the storage place. Then our target is to get 10 degrees Celsius. So with respect to the first scenario, we will be getting 14 hours it must take to cool. Next slide please. Next slide. The second scenario. Here the vegetable is initially 20 degrees Celsius, where in the first case we will be having 25 degrees Celsius. Now we have reduced it to 20 degrees Celsius. And we also increase the cooling rate, that is 0.183. In the first scenario, we have the cooling rate of 0.099 Celsius. Here same way, how we are using the Newton law of cooling, after we are getting 6 hours to cool. Here what we have done means, we have increased the cooling rate to 0.183 temperature and we have dropped the temperature of 20 degrees from the first scenario. Next slide. Here is the exact solution, like with respect to time and temperature. Temperature is of 25 degrees Celsius, it must drop to 10 degrees Celsius. With respect to time, is first scenario we are having 14 hours and the second scenario it will be of 6 hours. So we need to minus 14 minus 6, which is equal to 8 hours. So we are saving 8 hours of energy that is used to cool the vegetables. Next slide please. We have used AI techniques, that is PINN. PINN stands for Physics Informed Neural Network and PINN stands for Physics Reinforcement Neural Network. It is an optimization technique. Why we are using PINN and PRNN means we will be getting different types of data. This data may be structured and semi-structured. In the structured data, it is easy to take the insights. But in unstructured data and semi-structured data, we need to use some techniques. Here I have used PINN and PRNN, where it will be like we are having data. It may be of structured or unstructured or semi-structured. With the physical law, we will be getting the noisy data. Like in the noisy data, we will be having data, and with the physical law, we will be arranging the data also. represented by physical informed neural networks. Yes, ma'am. Can you before?
This one.
Yeah, ma'am. The orange color line is the PINN graph, that is the physically informed neural network, the data with the physical laws. Then it is with respect to time and temperature. The temperature decreases from 25 to 10. Here it will take 14 hours. Next. So first we have calculated with the exact, that is the manual calculation using Newton law of cooling. Now with respect to PINN, there is a difference that has shown in the graph also, but extra information is given. Next. The connection with sustainability. So then scalability. In the first example, we have seen the use of foods. Now we can apply this scenario with vaccination, that is storage of vaccination. From it will be maintained around some degree, such as it can be used in this also, and flowers also we can use, and seafoods also we can use. The conclusion. Everyone thinks maths is like an equation or solving some finding x, etc. But it is really used for this sustainability also. As before I have mentioned that sustainability is the golden key to solve the sustainable issues. So this I have given. With the traditional method or the exact solution, we have compared with the AI tools and we got better results also. That's all. Yes, ma'am. Like that, we have researched from some paper and we have used. Before slide, I have added, ma'am. Before.
Was it that randomly? It's nice. Work is very nice. This problem
from research paper I have taken, ma'am. It is actually a review paper. So we have taken the problem and we have drawn the graph and we also mentioned.
It doesn't look like it's a research paper. It's a new problem we formulated. Okay. The graph, whatever you have drawn, how did you draw the graph?
Using Python code we have drawn, ma'am.
You have the Python code?
Yes, ma'am, I'm having. In the paper it is attached.
You know Python?
Yeah, ma'am.
That means you have included. Done using Python.
Yes, ma'am. But the code is very long.
No, you were mentioning, when you were showing the graph, you were mentioning only about PINN. Physics involved. The graph has PINN value also.
Actually, PINN and PRNN is same, ma'am. What is the difference is PINN is the the minimum and PRNN is the upgrade version of this. Why we are using this? We will be.
You are mentioning you have told it as both you have used PINN
and PRNN. Physics informed neural network and physics. Because it is the upgrade form, no, ma'am. We do our aim is to get the approximate value for this first PINN.
Yes, ma'am. The first time factors can be high level. That is, we can use the carbonates level and then cooling timing also very high. But in the second scenario, we applied this PAN concept and time is reduced taking the cooling. Because nowadays we need the cooling in home and it's more relevant to sustainability.
Have an equation. An equation there. Mathematical model. You are model using an equation. Can you let me check? I know your faculty must be knowing it. Go to that mathematical modeling. What type of equation it is? This is the result. Okay. This is the result. And the you model it. Okay. That's a this one. What is the equation? Differential equation. What is the differential equation?
Linear differential equation. Linear differential equation.
Can you show the graph again? This just for you. This so similarly, so you must have learned in mathematics. So can you tell me about the functional form of this graph? When mathematics in BSc. Max is there? Then can you tell me about the functional form of this graph?
There is an equation associated with this curve.
With this curve, yes. That's what I am asking.
What is the equation?
It's not for you since you are doing these things. When you write some program also you should know. Suppose I am given a set of points. Is it linear? Some key I am giving.
Linear only.
Linear means straight line. It should be a straight line.
So what is the functional linear equal to?
What's the equation of straight line?
No,
What is the equation of straight line? It's all learning. It's like we are trying to make you people understand.
Definitely, I don't know.
That's what there is of trying to make you people understand. Okay. Just like I give Mars and Eve. Okay. We are really happy that you people are doing it, but do it with an understanding.
Function is nothing but solution. What you got from exact method, no, that solution is your function.
What is the solution you got? Go back and see what is the solution. You got a solution is there. No? What is the solution you got? This is a first order linear differential equation. Okay, and the solution, when you look into the solution, is in terms of what? What is the equation? That phi is equal to? It is in terms of E, exponential function. Do you remember how the exponential graph is?
Thank you. Next participant is NS132.
So far in the presentations we were having mathematical modeling, sustainability, and big things like quantum computing, AI, and etc. But we all know that we are living in this tech-savvy world. We are going forward with AI, quantum computing, and trying to get first in all these technologies. But what about those people who are lagging behind? And like, what about those people who are not even their doors are not even open to these kind of technologies? So I'll be specifically focusing on those people who are being led behind, that is the rural people and those who are living in the rural backgrounds, and how we can bring them forward, how we can make them join the race. So my name is Manu Francis, and I will be presenting the paper titled Mathematical Modeling for Sustainability in Rural Indian Mathematics Education 4-year series, a combination which has never been used before, and this is a novel idea. So now let us begin. Abstract is trying to explain in short what these terms, the mathematical modeling, sustainability, rural Indian education, what are the drawbacks in it, and how the 4-year series is able to meet the challenge, that is to bring those people forward, to make them understand, to make their mathematics education more engaging, and to solve the challenges like the limited resources or the lack of engagement, the rote learning system, and all those challenges, how we can make it interesting using the 4-year series concept. So that will be the abstract, and let's go to the introduction. So in the introduction, we are having the next slide. Rural Indian education system. So we see that around 65%, 65% of the 1.4 billion people in India, they are living in rural settlements. They're not having much advanced complex education systems, or they're not having that many resources, they're not having that much trained people to teach them difficult concepts or even basic ones. And only 74% of rural schools have having trained educators. But even when they are having these trained educators, what the problem is that they are having rote learning system. The classes are very disengaging, the people are feeling bored, and the students are not able to understand what is the what means, how the things that are taught in the classroom, how can they be applied to the real life, how can they be more interesting. So that situation is not being addressed. That is the problem. And NEP was introduced to challenge this problem, and fix this problem. And they were promoting contextual learning systems, but also they are also requiring a lot of resources to be implemented. But my paper will be focusing on how we can use 4-year series and plotting graphs to meet their challenges in a very cost-effective manner. So the next one. Why 4-year series? So there is an equation on the board which is very complex. I think some may be understanding it. We science students have been studying this one for past semester. So I will not be reading the equation, it is there. But it simply means that there are many periodic functions which are happening in our daily life. Temperatures, like if it is a typical summer day, there will be temperatures rising and falling. In the afternoon, the temperatures will be high. Nighttime, it will be falling. Then again, the next day, it will be high. Then again, it will go low. So it is like a curve which is going. The temperature is going in the form of a curve, and the Fourier series is trying to mathematically model these changes in the day-to-day life, and they're trying to mathematically show this how it is working. And that's why Fourier series I'm using it. And yes, in the rural settlements they're having challenges like how to make it engaging, right? So we'll also look at that. In rural settlements, of course, we know there will be a lot of farmers. They'll be more adjusted to their agriculture backgrounds, and or agriculture backgrounds. So how can we? That's why I'm using Fourier series because they are very much associated with nature as such. So I'm using Fourier series to make that association more what to say more engaging for them. Next one is why I'm using Newton's law of cooling. So as I said, they are more associated with agriculture. So they will be having problems like crop storage. What is the best time to store the crops, and what is the temperature in which they have to be stored. And so Newton's law of cooling is also being helped in applying Fourier series. Like it will be helping them to understand and what is the temperature that is required to keep the to cool down the crops, and what is the optimal temperature which is required. So there also will be using some equations which is showing like first of all let me tell you what is Newton's law of cooling. That is the rate of change of difference, the rate of heat loss. The rate of heat loss is directly proportional to the difference between the temperature of the body and that of the surrounding. So that is the Newton's law of cooling, and that will be used in the Fourier series to promote to understand what is the best optimal temperature. The next one. Now the course proposal, I'm trying to propose a course which is titled Fourier Series for Sustainable Rural Development. So in that course, the objectives and content and methods is given. That is, the objective is to understand what is Fourier series. So this course is actually for the classes from 9th to 12th, not too low grade students, but from 9 to 12, those students, they can make use of this Fourier series, because Fourier series, as I told, it is having this sine, cosine terms and all. So in this lower classes, they will be having this trigonometry classes, but so in that also we can introduce to them the Fourier series concept also. and the content will be same as trigonometry and the Fourier series, and the temperature and the solar modeling projects, which we'll be seeing in the next slides. And methods is we can use visual aids, we can take them to the factories, or group plotting methods. We can make use of graph papers. They can sit together and plot the graphs, and also local data projects which can be done in the local environments. So that is the course, and now let us look at the practical things. The next slide. So the practical example one is the temperature modeling. So here I will be taking the example for Maharashtra. That is, I have referenced the Maharashtra, what is that, tourism website. In that we have given, they are given the Maharashtra climate details. So in that we'll be seeing that the temperature is ranging from 20 degrees Celsius to 35 degrees Celsius, and using that model we can understand that how the temperature is fluctuating, and that I'll be showing in the figure in the next slide. The next slide, please. So using Fourier series, I have actually modeled the temperature variation. That is, as the time that is from 0 to 24. As the time is moving forward, the temperature is slowly rising, and around between 6 to 12, that is around 6:35, 6:18, the temperature is slowly starting to rise above the 25 degrees Celsius. So 25 degrees Celsius is the mark where the crop starts to get spoiled. So above the 25 degrees Celsius and around 6 p.m., the temperatures will be about 25 degrees Celsius. So that is the optimal time when we need to provide ventilation for the crops. That is, we need to provide some kind of ventilation using the Newton's law of cooling. We can provide some temperature variations so that the crops will not get spoiled. We can keep that below 25 degrees Celsius. So that is the concept, and that the temperature variation I have formed here using Fourier series. And this thing we are expecting the students also to plot these kind of graphs so that they can understand that what they are learning, the Fourier series which they are going to learn, that how it will be applied in the rural context. So this is the case of Maharashtra. Next one is the practical example from Rajasthan. That is solar energy. So for this one, I have a reference the Institute of Science, solar energy in India. One article is there about it. In that we are saying that in Rajasthan, if we are taking the solar intensity is being at 1000 watts per meter square at noon. So that phenomenon we are taking here, and that also will be fluctuating. So over time, solar intensity will also be fluctuating from a lower level. That is, it won't be always 1000 watts. It will be sometimes less than that, but the peak is 1000 watts. So that I will be using Fourier series to present that in the we show in the next figure. The figure. So this is how the Fourier series is used to show that variation in solar intensity in the case of Rajasthan. So around so before 6 p.m. itself, the solar energy, that is the charging is beginning, and after 6 p.m. also slowly it is coming down, and it will be peaking around 12 p.m. That is, it is becoming 1000 watts per hour. That is shown in the graph here. So I think students will be able to find this interesting and understand how this solar energy, which is also a sustainability concept, how that can be implemented in also in their rural settings. So that is also an application. So the next one. So that is the overall paper, and the conclusion is that how we can align this SDG4 NEP concepts, like national education policies providing contextual learning, how we can implement those ideas into the rural backgrounds effectively in a cost-effective manner, and also make sure that the system is not just rote learning. They are not feeling so much disengaged in the classes. We can make use of Fourier series and provide to them an engaging mode of mathematical education, especially in the rural backgrounds. And of course, we need to train some teachers because the teachers may not be familiar with this concept because it's a novel idea, of course. So we need to train the teachers and implement it and make it more expanding in the future. Yeah. So thank you. And yes, I've used these references, Sustainable Development Goals, and the different references. Mainly, I'll be focusing on the fifth one, that is Mathematics for Sustainability. That is Rowe and others textbook, Mathematics for Sustainability. In that, they are shown how this mathematical concepts like Fourier series and other mathematical concepts like differential equations, how they are used for sustainability issues. Then the next one. Yeah, these are also references in which the Maharashtra tourism, that one is given. Yeah, so that's all. Thank you.
It's a real-time data. The graph that which you have drawn is a real-time data. It's a real data.
That is 2022, I think. that data was collected.
Can you just go back to those graphs?
The graphs. Solar intensity or the temperature one?
This is
Solar intensity in Rajasthan.
okay.
Peaking at 1000 watts per meter square.
Time and how much you see charging one the intensity solar intensity. What is it
Yes,
using here? Charging threshold.
Charging threshold 300 watts per meter. That's the when the charging is actually beginning. Before that, it will be dead state.
This is the real time data.
Yes, ma'am. This is plotted according to the data. Yes, ma'am.
Where did you get this data?
This is the Indian Institute of Science. I've just taken the references here.
Website it is there.
Indian Institute of Science, Solar Potential in India. That is the article. The graph is made using Python, NumPy and Matplotlib library.
This is for Fourier sine series and that is Fourier cosine series. And this is Fourier sine series.
Both are cosine actually.
Both are cosine series. No, this looks like a sine series. This is cosine.
Sine 0. Cosine.
Can you just go back the one?
The equation is given, yeah, cosine series.
Both are cosine series.
Sine series passing through zero.
Passing through
The
zero.
first one is sine series.
Passing through one means that is cosine.
Cosine is 1.
This is cosine and that is sine series.
Sine series that is passing through zero.
Okay.
This is
Oh yeah, sine series. Okay, fine.
And this is for temperature variation.
This is for temperature.
Okay.
Case of Maharashtra.
This is all fine, but please do not try implementing for 9th degree because I don't think so that it's a right objective. If you want to do Fourier series, you need to have a knowledge on differential equation, you need to have a knowledge on integration, you need to have a knowledge on continuous. You know what is the
Bernoulli's
not-
theorem.
Yeah, it's
That
not
was.
9th grade, it's already the students are overburdened.
We can simply tell them how to make the graph.
Probably this is a good suggestion even now. It can be taken as an example, as a case study. Generally BBA, MBA they do case study, but engineering students they don't do it because a lot of challenges are involved.
Yes, ma'am.
So this can be probably if it can be shown for any engineering students, especially electrical students, if they take it up, it will be they get a good understanding.
Not for lower classes. Okay.
It's not the right objective. It's
We
not
expect
possible.
more from them.
You need to have a good clarity about the concept. It's not the right. Can you just go to previous slides? You have applied that Newton's law of cooling you have taken, and
Yes,
from that solution you
That is
have
actually a solution to the optimal.
and you have taken the cosine representation and sine representation.
Yes, ma'am.
Who's the mentor?
More clear, ma'am. And Chinbargo, ma'am. Okay, ma'am. Thank you, ma'am.
I don't know how much is your understanding, students' understanding. You have done Fourier series?
We are learning Fourier series right now.
Right now you are learning.
Yes, ma'am.
Fourier series. And can you tell me if that being the case, let me ask you some questions. Is it a finite or an infinite Fourier series?
That's actually.
Whatever you have taken is it a finite one or an infinite one?
It will be going like this every day. So infinite.
Go to your first slide and see whether you have written. Go to the first slide. The equation, first slide in the sense you have written, he was explaining about that. Next one. Where he has written the equation.
Is n equal to 1 to infinity?
Yeah, here you can see here.
Fourier series is 1 to infinity.
1 to infinity.
We'll keep going.
Do you know that there are,
Which ma'am?
you wrote this from where is that you have written this one?
The equation.
Ah,
That is the equation.
that's the equation. What is that A naught, AN and BN?
That is the n is actually being replaced with 1, 2, 3 and all. And based on that,
Okay.
and the T is actually temperature. The temperature of the specific time.
Did you find the value of A naught, AN, BN value?
Not exactly. I just gave the code in the Python and
You got the value. When
Yes,
you
ma'am.
have that Python code, you should have included the Python code and you should be knowing what is the A naught, AN, BN. Those are all
Okay.
Oil is constant.
Yes, ma'am.
You should know when you are writing something, putting there in your slide, you should know what exactly.
Actually, I'm not manually calculated the ones.
No, it is not necessary to cover a research paper. Nobody calculates it manually, but you should know what is A naught, AN, and BN. Do you have that value, A naught, AN, BN value? Do you
I have the code with me actually.
Yes. It is written. Can you go to the graph?
Chaitra, from stage you take one pic. Chaitra, from stage you take one pic. It will be liquid. Yes.
You can see that the value is written there.
But that is not manually calculated. So I'm not sure.
How are you relating it with NEP?
Because my idea is that these in the rural education system, right, they're having so much rote learning and everything. Their classes should be made engaged. They should not simply just study trigonometry, pi hat the formulas and just go home. They should be knowing that these things are applied in your agricultural field.
Sustainable education.
Yes, ma'am. Okay. Thank you, ma'am.
The next participant is NS119.
Good afternoon, everyone. I'm Sarika. I'm here to present my paper, Achieving a Sustainability in India, Analyzing Carbon Neutrality Sceneries Using Novel Fourier NRDL Approach. From this paper, we are going to see how India can attain the carbon neutrality using the different methods. Now, here we have selected a Fourier NRDL approach. Next slide. So, before starting, India's rapid economic expansion increased energy demand and population. So, when we have an energy demand, now we are using more than 50% from the coal-based, which emits more carbon dioxide. And we have and India has pledged to attain the carbon neutrality by 2070 and also to get 50% non-fossil energy by 2030. To attain all these things, if you use the coal as our energy source, it won't be useful. So to have an alternative, we have a nuclear energy which provides a stable and low carbon product. And this nuclear energy is benefits like it's not intermittent like solar or wind, and it is operational since from 1960s with expanding research and development. And the challenges from this nuclear energy are radioactive waste, safety concerns, and public resistance. And whenever we see the paper, they almost use like the carbon emission data and others. Here we are for a change we are using LCF factor, which is the load capacity factor, which is equal to the ratio of biocapacity and ecological fringes, a more holistic measure. Next slide. And before we go into the topic, we can see the few charts. Like the first one is the global carbon dioxide emission by top 10 emitters and rest of the world. From this we can see that China is the largest emission of carbon dioxide, followed by United States, European Union, and then India. India stands as the fourth emitter globally. Next slide. And this is the global historical cumulative emission. From this we can see that the developed nations emit more carbon dioxide than other countries. Next slide. And here we have a data for India carbon dioxide emission per capita from the year of 1970 to 2022. And in this we can particularly see at the year of 2000 we have a rapid growth of carbon dioxide emission, and these things are due to the industrialization and urbanization. Next slide. And for this our paper we have a theoretical background. In this we are using SEC hypothesis, which stands for load capacity curve hypothesis. In this it is a U-shaped curve between gross domestic product and load capacity factor. And this is when the economic growth in a country, it degrades the ecology, but after attaining a certain level of stability, using of
green nature and green technology, it stabilizes and it also allows to ecology to come balance, and it also promotes the sustainability in ecosystem. Then we have, and we can compare this with the EKC. EKC stands for environmental visits curve. It's an inward curve with the GDP and the pollution. Then when we have this LCF factor, load capacity factor, with the value of this particular factor, we can see whether we have an ecological balance or not. If the LCF factor is less than 1, we can say it's ecological deficit. We need to improve. If the LCF factor is greater than 1, it is enough for us to, and you can conclude that we have a stable ecosystem. Next slide. And the literature review. When we have go through about this carbon neutrality, we have a mixed results globally. When we take the few things I have mentioned here, first one is the UK. UK has the, when the NUC stands for R&D nuclear R&D investments. Whenever we have the nuclear R&D investment shops, it will improve ecological quality. In Japan, clean energy of R&D reduces carbon dioxide. But the OECD countries, which stands for Organizational Ecological Contribution and Development, it has almost 38 countries in that, the OECD countries. They have no significance in this relation, because whenever the economics grows, it doesn't have any relationship with the ecology. Then we have few gaps, like no asymmetry R&D analysis. Still, so far, they have always taken the symmetrical values and linear regression properties. They never considered about this asymmetric R&D analysis, and also no one is taking forward, and they are coming with the LCF factor. So today we have a paper to cover all these gaps. Next slide. And the research methodology. And here we have this equation based on the STIRPAT framework, which analyzes population, affluence, and technology. And the variables here is LCF stands for environmental by T, and PY square stands for GDP and its square, and NUC plus and NUC minus. It all the nuclear R&D shocks are positive and negative. And then we have a UR stands for urbanization. Then we are using the Fourier NRDL method. We are using this particular method to capture the asymmetric methods, because whenever we have a carbon dioxide emission, it won't be stable. Due to some type, it will be increased rapidly, but due to some other concern like COVID-19, the carbon dioxide emission will rapidly decrease. So to have these asymmetric properties, we are using the NRDL model, and accounts for smooth structural break. So to have the smooth structural break, because whenever we have some data changes, we can't each and every time we can add the year or the value. To have that smooth function, we are having Fourier series. So in combined, we are having Fourier NRDL method over here. Next slide. So when we have seen the STIRPAT method, we have used only NUC. It means linear. But whenever we have carbon dioxide, it has a both positive as well as a negative effect. To differentiate, we are taking that NUC in two factors. It has NUC plus as well as NUC minus. And then we had adding the Fourier terms into this. The Fourier terms means the sine and cos wave functions, and that is the third equation which we are using for this particular paper. Next slide. And the data estimation. To analyze this particular thing, we have taken a data from the 1978 to 2024. And the sources were like World Bank, IEA, International Energy Agency, Global Footprint Network. These are the sources which we use to take the data. And all variables are log transferred. The log transferred is a mathematical method which we use to test the stability and to make all the data to be stable. And then we have the few steps here to find whether the data is stable to use the NRDL method or not, and also analyze whether we can attain carbon neutrality by 2070. And these are the methods. First one is unit root test, second is co-integration test, thirdly Val test for asymmetry, and last diagnostic and stability test. Next slide. And this is the descriptive statistics. Like here we have taken the GDP per capita from 1970 to 2022, and as well as the urbanization growth rate, and then the LCF drop, whether we are attaining towards the ecological stability or not. If you check that, it is rising ecological deficit because we are going backward to the ecological demand when we check for this LCF, and the NUC investment showed modest increase. Gradually these LUC investments are growing, and the environmental pressure growing despite economic progress. And stationary tests are, we call as ADF or Fourier ADF test. ADF stands for augmented Fuller test, and we do this particular test to find whether the data which we have taken is stable or not. And from the results we can take that all the variables are of order 1 and 0, which is suitable for using any RDL method. Next slide. Then we have the co-integration test. We do this co-integration test to know whether we have the long-term relationships or not. When we did this co-integration test, we have concluded that long-run co-integration exists with a significant level of 1%. Next slide. And we have an asymmetry test. We do this asymmetry test to check whether the results of the positive and negative shocks are both same or different. So when we did this particular test, it justifies Fourier analysis separately captures positive and negative, because all times these positive and negative shocks are not same. Next. And then we have a long run coefficient. From this test we can see whether this particular equation or the method has a long run relationship for the longer time and whether it's a short time. When we did this, the long run relationships are significant and consistent with EKC and environmental degradation hypothesis. Next slide. And we have the short run dynamics, which model dynamically stable and quickly adjusts to the long run equilibrium. And then next. From this we can see that India is in a realistic path to attain the carbon neutrality by 2070, and whenever we have the investments in nuclear R&D, it has a long-term impact on the environmental quality and sustainable growth. The urbanization and economic growth must align with the sustainable goals. For all the reasons, we can confidently say that India can attain the sustainable carbon neutrality by 2070 if it follows all the present trajectories in nuclear R&D investments and policies. Thank you. And these are the references which we used for this particular paper. It's only LCC hypothesis, and it is a reverse process of EKC. EKC is environmental quizzes hypothesis. 4 tests, ma'am. 4 tests. First is stationary test, and secondly co-integration test, and next test.
And this ADF, is it not, are you referring to this, what is this ADF? Is it not the
It's an augmented Dickey-Fuller test. I missed Dickey, ma'am. Augmented Dickey-Fuller test.
And you have written that unit root test, no? It's like it is performed for ADF is performed for unit root test. You know what is that unit root test?
To find whether the things like the data is stable or not. If it was in a stable at the present state, we can say it is of order 0. If it is after first differentiation, we will say it is stable after the first, its order of 1. Normalization.
How do you, what is the tool you have used to get all these results?
Ma'am, this is the data which is available over the Google from our Indian websites.
You got those data. How did you get these results? All the statistical results, whatever you are mentioning, you have done this unit root test, ADF method you have chosen.
Yes.
Okay, then SOMS test, wall test, which is
It's a STIRPAT framework.
STIRPAT.
STIRPAT.
What the hypothesis? Can you go to the hypothesis?
Next. Next.
This is a result, stationary result of your next one, the hypothesis. All these tests has been given. You have
Evolution only LCC hypothesis.
I'm not able to see the hypothesis. P-value, you have written the p-value. What is the calculated value? P-value is 0.023.
Yes, ma'am.
That is calculated value using geometry and Python.
That's what, but the hypothesis is missing.
We given coding. Coding. This is not manual part. We use Python coding and the geometry part to calculate it. There is a lot of data now, so it's very difficult.
No. The slide, she has written that the reject the symmetry. So what is that? That means asymmetry is confirmed. So what is that she is trying to test? The testing of hypothesis is being done here.
We consider H naught value is negative and positive.
Positive.
But value is less than 1, that is asymmetry.
That's what I was asking. That is a hypothesis. She is not able to.
Paper, hypothesis H naught. H naught is positive and minus, but our result is less than 1, so that is
Thank you.
As we conclude this enlightening session, I want to take a moment to express my sincere gratitude to each and every presenter on this panel. You all contributed different viewpoints on how innovation, sustainability, and technology interact. This panel genuinely demonstrated the breadth and depth of current research in green computing and smart technology. In addition to demonstrating technical proficiency, your speeches demonstrated a profound understanding of the urgent social and environmental challenges of our day. Such progressive ideas for creating a more efficient and sustainable future were heartbeating. I also extend my gratitude to our esteemed panel members, Dr. Muhammad Imran Khan, Dr. Imran Basa, and Dr. Imravati, and Dr. Kavita for their presence and engagement here. Thank you to all.
Now it's validity function. Now we can keep using it. After this, we can
Nothing is being solved. Why is it
Phone mobile 13 14 IQ 14 13 IQ 9 Z9
Please rise as our dignitaries arrive. Please be seated. Every ending is a new beginning waiting to unfold. Good afternoon to one and all. As we gather here for the valedictory ceremony of this enriching seminar, our hearts are full with insights, inspiration and renewed responsibility. The National Seminar on Sustainable Computing and Cosmic Innovation has been a canvas of ideas and a chorus of collaboration. Now, it's time to reflect on what we have learned and to celebrate what we have shared. What gets measured gets improved. I now invite Ms. Richu Baby, our event coordinator, to present a comprehensive report on the day's sessions, highlights, and key takeaways.
Respected dignitaries, esteemed speakers, members of the faculty, distinguished guests, and dear participants. A very warm good afternoon to each and every one of you. It's both a profound honor and a distinct privilege to stand before you to deliver the report of the National Seminar on Sustainable Computing and Cosmic Innovations, Pathways to Green Technology for Business Evolution, hosted by the Department of Computer Science and Science in collaboration with IQAC and IIC of Christ College of Science and Management. This one-day academic confluence was conceived as a platform to deliberate on the convergence of sustainability, technological advancement, and evolving business paradigms. Our aim was to foster conversations around environmentally responsible computing and space-based innovation while encouraging collaborative interdisciplinary thinking. The preparation for this seminar commenced over a month in advance, marked by tireless planning, coordination, and academic scrutiny. Abstracts were invited from scholars and professionals, which underwent a rigorous selection and review process by an editorial board. Only the most relevant and academically sound papers were shortlisted for presentation, reflecting the diligence and integrity of both our department and the organizing team. The seminar sought in essence to heighten awareness about the environmental impact of computing and to explore the promise of cosmic technologies in addressing sustainability challenges. Equally, it aimed to inspire cross-sector collaboration and ethical innovation as key instruments in shaping the future. The proceedings of the day began with a solemn invocation and the ceremonial lighting of the lamp, which symbolizes knowledge and enlightenment. Ms. S. Athilakshmi, Head Department of Computer Science, delivered a heartfelt welcome address, followed by an inaugural speech by Reverend Father Jose Totatil CMI, Manager, Christ Group of Institutions, who reminded us of our shared ethical responsibility toward environmental stewardship. Our intellectual discourse was enriched by two distinguished keynote speakers, Dr. C.S. Stalin, Professor at the Indian Institute of Astrophysics, Bengaluru, offered deep insights into how cosmic innovations could serve terrestrial sustainability. Dr. Matthew Manimala, former Director of Science, Bengaluru, eloquently emphasized the strategic integration of green values into business and entrepreneurship. We were gratified by the enthusiastic participation of 51 delegates from diverse academic and professional domains, whose involvement added depth and dimension to our discussions. A highlight of the seminar was the engaging panel members featuring a distinguished set of professionals and academicians. To name Mr. Ajay Vaishnav of Infosys, Mr. Harshavardhan Singh of Wipro, Dr. Imran Pasha and Dr. Imran Khan from the State Forensic Laboratory, Karnataka, Dr. A. Kavita of Government Arts College, Tamil Nadu, and Dr. M. Revati from NMIMS, Bengaluru. Their insights offered a broad spectrum of perspectives on sustainable technology and innovation. From today's deliberations, a few clear takeaways emerged. Sustainability must be viewed as foundational to technological and economic progress. Green computing requires responsible choices at every level, from design to deployment. And importantly, space-based technologies are no longer distant abstractions, but practical tools with the potential to address some of our most pressing environmental concerns. As we draw this inspiring seminar to a close, I wish to place on record our deepest appreciation to the management of Christ College of Science and Management. Our sincere gratitude extends to Reverend Father Jean Stowe CMI, a visionary principal whose unwavering encouragement and strategic guidance made this event possible. We are immensely grateful to our esteemed keynote speakers, panelists, faculty coordinators, members of the editorial board, dedicated student volunteers, and each participant who contributed to making this seminar a resounding success. Let us not allow the momentum of this day to fade. Instead,
Let it galvanize us into sustained action. Let it remind us that every innovation carries with it a responsibility, and that the future we are building must be not only smarter, but also greener, fairer, and more humane. Thank you all, and may our collective pursuit of knowledge continue to illuminate the path to a more sustainable and enlightened tomorrow. Thank you.
Thank you, ma'am. Success is not the key to happiness. Happiness is the key to success. We are now honored to have our beloved principal, Reverend Father James John CMI, to officially close this academic forum. Father, please.
Due to the shortage of time and people are waiting for the bus to be board, I don't take much time. One word of appreciation to the Department of Science and Department of Computer Science, both their heads and the teachers and students. So I'm very proud of you for having the national seminar conducted. So 1 month preparation, rigorous preparation, and they were under my scrutiny. So they were successful in coming up with the national seminar. And I take this opportunity to congratulate all of you for putting up a lot of effort to make it successful. And thank you, dear students, for being wonderful participants. And I take special note of appreciation to all the jury panel members, because you came from faraway places, and I was listening to the questions you were asking too, and that was really amazing. And thank you for being with us this day, and we are really appreciating your readiness and willingness to be with us, and we hope you will join us at the future endeavors as well. So hoping to have you again here in this campus. And with this note, I officially declare this national seminar closed. Thank you very much.
Thank you, Father. Appreciation is not just a gift, but a powerful one given generously. It uplifts others and strengthens relationships. To express our heartfelt thanks to our distinguished panelists who enriched today's session, we invite Reverend Father James John CMI to present a token of appreciation. At first, we have Mr. Ajay Vaishnav, Software Quality Engineer and Automation Tester at Infosys, Bengaluru. We invite you to the stage to receive a token of appreciation. Next, let's welcome Mr. Harshavardhan Singh, Associate SAP ABAP Consultant, Pro, Bengaluru. Sir, please kindly come forward to receive a token of thanks. Please give him a huge round of applause. Joining us now is Dr. Imran Pasha, Scientific Officer at State Forensic Department, Karnataka. Sir, please kindly come forward. Coming up, we have Dr. A. Kavida, Assistant Professor at Government Arts College, Hosur. We welcome you to stage, ma'am. Up in the line, we have Dr. Muhammad Imran Khan, Scientific Officer at State Forensic Department, Karnataka. Sir, please kindly come forward and accept our token of appreciation. Finally, we have Dr. M. Revati, Assistant Professor at NIMS Bengaluru. Ma'am, please join us on the stage to receive a token of thanks. Don't wait for the opportunity, create it. We are now moving to the prize distribution ceremony to honor those who demonstrated excellence, engagement and enthusiasm throughout today's event. Now, it's time for the most awaited moment of the seminar, the Best Paper Presentation Award. This award recognizes outstanding research, clarity of thought and excellence in presentation. And now, we are proud to present these awards to Manisha Dal, Manya Tuli, Abin Abraham Matthew, under the guidance of Afifa Taj. I welcome the winners to the stage. Please give them a big round of applause. Congratulations to the winners. Once again, a heartfelt congratulations to our winners and a sincere appreciation to all the participants for their valuable effort. Thank you, Father. Gratitude is the fairest blossom which springs from the soul. To express our heartfelt gratitude to every hand and heart behind this event, I invite Dr. P. Rajalakshmi, Head of the Department of Science, for the vote of thanks.
Good evening, everyone. It's my proud privilege to deliver a vote of thanks on this special occasion. First and foremost, I thank the Almighty God for His abundant blessings and grace, made this national seminar on sustainable computing and cosmic innovations, pathway to green technologies for business evolution, a resounding success. Without His guidance and provisions, this event would not be having possible. On behalf of the Department of Computer Science and Department of Science, in association with IQSC and IIC, I express my heartfelt gratitude to all who contributed to the success of this seminar. I extend our sincere thanks to Father Joseph Dr. CMI, Manager of Rice Group of Institutions, for this inspiring inaugural address, and for the James George CMI, our respected principal, for his constant support and encouragement, which greatly contributed to the success of this seminar. A heartfelt thank you to our keynote speakers, Dr. C.S. Stalin, Professor at IIA, and Dr. Matthew J. Manimala, former Director of XIME, Bengaluru, for sharing their deep insights and valuable perspective with us. We are also immensely grateful to our distinguished panel members, Dr. Imran Basha, Dr. Mohammad Imran Khan, Mr. Ajay Vaishnav, Mr. Hashwardhan Singh, Dr. M. Revati, and Dr. Kavita, Dr. Father Jitu Matthew, Dr. Sister Binu Judge, contributions which truly resonated with this theme of sustainable and innovative technologies. My sincere thanks to Mrs. Adilakshmi, Head Department of Computer Science, one of the key member for the organizing committee. Thank you, ma'am. A special thanks to organizing committee, Ms. Richu Baby from Science Department and Dr. Vijay Lakshmi from Computer Science Department for their well-documented report and seamless coordination throughout the event. I would like to extend heartfelt appreciation to the invitation team, registration team, editorial team, printing team, a technical support team, hospitality team, and all our student volunteers from the Department of Computer Science and Science. Your tiredness behind the scenes of the efforts endure a smooth and successful flow of the entire seminar. And lastly, a sincere thank you all the participants, faculty members and students for their active involvement and gracious presence, which add meaningful and vibrancy to this academic gathering. Let us carry forward the spirit of sustainable innovations and continue to pursue the knowledge that builds a greener and smarter future. Thank you once again, and may God continue to bless all our endeavors with success.
Thank you, ma'am. The future belongs to those who believe in the beauty of their dreams. As we draw this academic symphony to a close, may the resonance of sustainable thought echo in all our endeavors. Let this not be the end, but the beginning of more conscious innovation. Once again, thank you all. Please raise